very much, Lynn, and for the invitation, and really good to meet you all virtually. Apologies too up front. I think I'm coming down with the flu, so I'll probably be sipping on water a lot through this session. And I'm hoping I can squeeze it all into 30 minutes. So really quickly too, we've got a bit of an interactive bit at the end. So if you can stick around to the end and you do have an iPhone or Android on you, then you can all play along at your desks. So really quickly, I'll give you a super quick background just on me to set some context. I started out as a learning designer back in the early 90s, and then kind of through sheer luck, I became kind of ensconced in emerging technologies, kind of first as a learning designer, then as a programmer, which I didn't last very long at. I think I was the world's worst programmer, but what I did realise was that I could solve problems, and it also made me really appreciate great programmers and mathematicians. After that, I really moved into the kind of user experience space kind of in the late 90s and worked heavily in kind of R&D for various companies across telco, media, education and finance. And then with companies have kind of developed high transaction finance platforms for mobile payments and video streaming and platforms for educational recognition of prior learning and assessment, and also enrolment systems as well. But the last 12 years, really, I've been working kind of predominantly in the AR and VR space, or the mixed reality space. And in 2009, let me just flip through here. Sorry, Lynn. Here we go. So that's me. So in 2009, we built the world's first AR content management platform that kind of enabled non-developers to create and publish content to native AR apps or browsers, mobile ones at that time. So you might remember Layer, which is still around, and Geneo. So the company that built Geneo, Mateo, who are one of our partners, were acquired by Apple, and that team has basically developed the underlying tech behind Apple's AR kit, which we'll talk about in a little while. So way back then, our platform was called BuildAR or Build AR. But users, even though it had a web-based creation side, kind of a drag and drop interface, you actually had to download and install the Layer or the Geneo app to actually interact with any experiences. But I mean, really, everyone in our team loves the web, and we all come from a web-based background. For us, we really see the web is the world's largest development and experience platform. It's also got the highest number of developers and content creators. And I think most importantly, and I'm not sure if it's a word we should use today, but it's super democratic, or, it's supposed to be. So it's really open, it's easily accessible, and I think really importantly from an education perspective, it's really inclusive. So by kind of having BuildAR out there, we really saw that there was an appetite for web-based tools, even way back, kind of 2009 through 2012 for creating these kind of mixed reality experiences in the web. And we really saw that the apps that you had to download to play them were almost a bridging technology until the kind of necessary standards to support it in the web were both defined and also supported within the web browsers. And I really feel that that's kind of the case, or becoming increasingly more the case for apps in general as well, with a lot of the app fatigue we're seeing from people. So basically we developed OAR. So it's an entirely web-based creation platform. So it enables, again, non-developers, creative technologists, learning designers, graphic designers to create multiple modes of both augmented reality on the web, VR and 360 experiences that can all be interactive. And so all of those modes can also be kind of seamlessly woven together to create kind of rich immersive experiences. And then you can also add your own kind of, it's got a really simple drag and drop interface. We'll have a look at it later. But developers can also further extend experiences by adding their own CSS, JavaScript, and HTML. And then people can actually interact with the experiences by just opening a URL in the web browser on their device, or automatically detects the device, the operating system version, the browser version, and then we adapt, or the platform adapts the experience and the interaction models to the capabilities and capabilities of the browser and the device, and the form factor of the device as well. So really we're trying to, I guess, take away as much of the friction points as possible. And we'll talk about that a little bit later as well. So mixed reality in the web, we've really been working with defining a lot of those standards along the way, working with the browser vendors. My co-founder, Rob Manson, is an invited expert of the W3C. So that's really the web standards governing body. He's head of the AR community group for the W3C also, and an invited expert with the Chronos group and the ISO. And I think the last 12 months has possibly been the first time in our whole journey that we've not been seen as heretics and kind of called crazy. So we're pretty excited that now, you know, this kind of movement behind AR and VR on the web is really taking hold. So where I'm going to start is, I think, demystifying some of the terms that we see around mixed reality. And I think then diving more deeply into the different modes of AR as well. So I'm hoping that at least some of you, but if not most of you, got to see Tim Clapdaw's excellent intro session to mixed reality a couple of weeks ago. And I'm going to kick off by kind of, I guess, extending some of those concepts and introduce really or unpack the definition of mixed reality a little bit more. And so also for anyone that hasn't seen Tim's session, I'm going to provide a framework, I guess, for this session as well. So this on screen now is Milgram's mixed reality continuum. So Paul Milgram, who is currently a professor at Toronto University, basically came up with this in 1994. So he said that if you look at on here, we've got reality on the far left, so that's the real world or the fleshy meat space that we live in. And on the far, actually it's probably reversed on this side, but on the other side we've got virtual reality. So that's that entirely virtual space where nothing is real. And then in between we've got two other modes. So next to reality, we've got augmented reality, which is really that integrating or overlaying digital objects in the real world. And then next to that, we've got augmented virtuality. So that's really where you've got a virtual environment, but you're integrating aspects of the real world into that environment. So if we go here, let me just make sure. Yep. So I'm just going to show you a quick version of Milgram's continuum, illustrating the different modes again, but this time it's all in a web browser and this just happens to be on a computer. So it was done a couple of years ago now. So a few things, or the technology's moved along, but we can talk about that in detail. Oops. So we've got reality on one side, virtual reality on the other. Okay. So as we go through, you can see that this is all a spatialized environment. We're moving around. And to the left, and so we're in virtual reality, and you've got some 3D objects sitting in there. Then we've got the ability to turn it into stereo mode. So I think if you saw Nat and Claire's presentation last week, you can pop it into, say, Google Cardboard or a different viewer and see that. Then we've got augmented virtuality. So this is where I said you've got the real world projected into this virtual space. Okay, and that's a live stream in this case, or was when it was recorded. But that can be literally any data coming through from the real world in that case. And then on that far side again, you've got reality, so that real world data coming through. And then if you turn on augmented reality into that space, you can see that tracking is now possible. So in this case, it's a marker, but I'll show you later now, any real world photo or image is actually able to be turned into AR. So here you can see that it tracks a digital object in the real world, and that's AR, and this is completely web-based. And because this is just one type of sensor data, you can project that into the augmented virtuality scene as well, which you'll see in a minute. So if you hide it there, here we go. That allows us to move the marker content around inside the 3D virtual space. And literally you can use any other type of sensor data in this context as well. So that's just a quick overview of that in that sense. Cool. But then the term augmented reality in and of itself was coined by a man called Tom Cordell at Boeing in 1990. So Tom was basically tasked with coming up with a way that plane engineers could easily and quickly access the schematics and related maintenance information for the planes and for different parts of the planes. So he was asked to come up with an alternative to the really expensive kind of diagrams and markings that they used to guide the workers through that. And they used to basically print them out, put them on plyboard on the floor. It was a horrific experience. So he basically proposed replacing those with head-mounted displays that showed the instructional schematics that the engineers needed to do their jobs in the context and at the time that they actually needed to do that. Obviously, way back then, it was a fairly cumbersome process, but that was really the first time it had been used, especially in a commercial sense. And if we go through to the actual definition of AR, this is by Ronald Zuma, and he coined this in 1997. So he was a really early pioneer and researcher of AR and kind of VR tracking systems. And he developed the first kind of AR tracking system back in the 90s where the virtual and the real world stayed registered together even when the user moved around. He's currently at Intel Labs and, you know, leading a lot of their kind of groundbreaking research still within the AR and the VR space. So he said that, you know, he's got three really distinct kind of, I guess, points that he defines as being true augmented reality. So it allows the user to see the real world with virtual objects superimposed. And he says that it has to combine the real and virtual. It has to be interactive in real time, which I think is really interesting, and registered in that 3D space. And you'll see quite a lot now, you know, people are saying that, you know, Snapchat and Instagram and things have kind of got AR capabilities where they're just putting digital content over photos. That doesn't fit within this definition, but I think, you know, this definition really should allow for some of that fuzziness as well, because at the end of the day, users really don't care about that. If we think back to kind of Milgram's continuum and that it was really called the mixed reality continuum, we're starting to see that mixed reality now is really, I guess, associated with, in a lot of people's minds, with Microsoft HoloLens. And Microsoft doing that has, I guess, muddied the water a little bit. So what's happened is that a bunch of folk in Silicon Valley, and led by Qualcomm, who are one of the world's kind of biggest chip manufacturers, got together and have coined the term XR, which really stands for extended reality for short. So in essence, it's exactly the same as mixed reality, but I think you'll start to see this term XR, or extended reality, more and more. So it's not just yet another kind of computing paradigm. It really is just mixed reality, or that combination of VR and AR. Okay. And so where are we at today from state of the market? And I think a state of the market is really important to talk about, just to set some context for kind of the years ahead and moving into this space, especially from a learning perspective. What we're seeing is a huge flurry of activity in the market, from investment to research and development, new products, commercialization. And there's a bunch of players jostling to kind of be the default facto for this next computing revolution. And I think, and we're already starting to see it, there's going to be a real shakeout over the next kind of 3 to 5 years in this space, particularly in hardware. So you'll see a lot of the initial players either acquired by some of the larger players, or they're going to disappear altogether, and we definitely have started seeing that. So the current makeup of the market really includes kind of headsets and glasses, cameras, especially the kind of 360 cameras that you're getting, other sensors, so kind of haptic sensors to provide those external feedback loops for your body, such as vibrations, things like that, which is starting to be used more in the kind of VR gaming space. And then you've got kind of content creation and management. And that's really the area that kind of we play in, or I play in with my team on that. And so right now, you know, a lot of the hardware, and definitely the VR hardware, has been the domain of gaming. So predominantly things like the Oculus Rift and the Vive, and the HoloLens, and even Magic Leap and things like that. But they're prohibitively expensive. So they're kind of $3,000 to kind of $5,000 plus per kit, which is a huge outlay for most people, even for bigger organisations. And a lot of it is not particularly portable and comes with a lock-in to a specific platform. So they're really trying to do the, once you pay, you need to stay in that environment. But definitely the more accessible from kind of a cost and mobility perspective are the cardboard type devices that Nat and Claire were talking about. And they're literally the cardboard. So put it together yourself, a little bit of cardboard, drop the phone in. And the kind of hybrids of that to then the more sophisticated kind of Daydream View, Samsung Gear VR, and all of those clones. And then now, just in the last few months, we've got things like the Oculus Go coming out, which is like Google Daydream on steroids. It's a completely untethered, portable standalone device. You don't even need a phone to drop in it anymore. It's great. It's really, really great. And when we compare it even to experiences on the Vive, in that VR state, it's really comparable. And these are sub $300, which is awesome. And then you've got, from an AR perspective, in the last few months, we're starting to see devices come into the market like the Lenovo Mirage Solo, which is this. So that is a device that they're calling it a mixed reality device. So it enables you to experience VR, but then also AR in that kind of see-through mode as well, and use a hand controller for those. Content creation we'll talk about in a bit more detail, but really I think for these technologies to really take off and become acceptable from a content creation perspective, there needs to be a way to create that content without needing to be a developer or high-end production company or development company to make it cost-effective and efficient. And then I think to set up for the discussion around using the technologies as well in that educational context, let's look at a couple of the driving kind of market factors that we've got. So there's a whole heap of hype around these VR headsets at the moment. But the data, this data has been updated recently, and you'll see that the actual trends around the shipments of VR and AR headsets the last kind of 3 years across 2016 to 2018 is a lot lower than what they're forecasting for 3 years' time. And these actuals are about a half of what they were forecasting. So 2018 was forecast to be up in the kind of 25, 30 millions before they revised it. But that's, you know, it's fascinating to see that it's not actually catching on from a consumer perspective as quickly as what people were forecasting. However, I think, you know, adoption will take off there. But what is interesting to note is on the right-hand side, you've got the pie chart here. And in that other sector, that really is those low, or that, you know, low cost kind of inexpensive Google Cardboard type of device, and those portable headsets like Daydream View and the Oculus Go. So the Oculus there at 4%, and the Vive, they're the tethered, more expensive headsets we were talking about. Okay, and then also if you look at the kind of global smartphone market there, you'll see that the red or pink line there is the year-on-year growth. So over the last few years, it's been declining steadily to the point where last year it basically hit 0% growth. So we're looking at a completely saturated market globally. Pretty much every person has a phone or a mobile device in their pocket at any one time. So that makes it the perfect device to basically, you know, I guess, have adoption of these VR and AR technologies on them, because it's always there, it's easy and accessible. From a global perspective, you've got the majority of people on Android devices with not that many on iPhone. But if you look at the Australian smartphone market, and this is really interesting, if you're in Australia and creating content for Australian audiences, they're almost 50-50. So Android just below 50%, and iOS, so iPhones and iPads just above 50% there. And then you move into the AR kind of smart glasses market, and these have been a really, and still are a really small proportion of that global kind of AR VR headset market. And predominantly at the moment they're used in logistics and in defence for training and that type of thing. And so even with that, you know, fairly significant growth forecast over the next 3 to 4 years, we're still really only looking at just under 23 million units globally by 2022 from a forecast perspective. So that's a pretty small market. So it really says that mobile is going to be the dominant form factor from an AR perspective, absolutely, for the next 5 to 6 years at least. And then when you look at this as well, you'll see that the segment that's used in from an AR headset perspective is absolutely just in the commercial space, and forecast to grow predominantly in the in that space as well. So from a consumer perspective, they're more likely to have VR headsets than they're ever likely to have an AR or AR-specific headset itself. And then if you look at the forecast for just how big that market is going to be, again, they've revised those forecasts down or based on actuals to the end of 2018, but within the next 5 years, it's going to grow unbelievably. So if we look at right now, how many people can actually use AR and VR at this moment? So if we think about the head-mounted only applications, so those that you can only view in the head-mounted displays, there's really only 12.4 million devices capable or bought by the end of this year. And from a mobile applications perspective, we have 2 billion mobiles or more actually now in the world. And so, you know, they can download AR or VR specific applications to their phones. But if you look at the web as a platform and a delivery method, you look at the web being supported on PCs, on head-mounted displays, on phones and on tablets, then you've got an audience right now of over 3 billion people that can start using AR and VR and accessing, both creating and accessing these experiences just on their standard web browser, which is pretty awesome. And when I say that, I mean absolutely with no plugins or additional installations. So if we look at that, how do we actually view these experiences right now? So if you've got a head-mounted display app, so you're using it on a Vive or a Go or that type of thing, you've got to have the suitable head-mounted display. You've got to have a valid account with the vendor's app store. You've generally got to complete their kind of first use sign-up process. Then you've got to search and find the app in their app store, download and install it through their app store. And more often than not, that requires a system update or an app update or both. And then finally, you can kind of select and download, select and play that downloaded app. And then pretty much the same with a mobile-only app. So you've got a lot of friction points, I think, on the way between that first step of being aware of an experience existing to actually being able to use it. And I think the longest or the most steps we've counted on one was 27 steps from being aware of, and this is for a mobile AR app, being aware of it to actually starting to interact with it, which was extraordinary. And then on the web, if it's just a web AR or VR experience, you literally click on the link to open it and it opens and you can start interacting. So it's a fairly friction-free process. And then in terms of creating that as well, HMD only apps, so head-mounted displays, it's mainly in the realm of a developer. So you either need to hire one or be a developer or a team of developers. For each one of these different platforms, you generally have to get to know how to deal with the various issues and quirks on that developer SDK for that target platform. You've got to go through that whole development process, test it on the vendors' platforms, convert all the media so that they're in the right formats. And then generally once you've done testing, submit your app for review and approval, then publish and distribute the links to one or more different app stores, and then create that promotional content to drive people through it. And then quite often, if you have to develop for different platforms, you'll be doing that process again and again. Really similar from a mobile an app perspective as well. But again, for the web, it's really like when you're doing web development, and if you're using WYSIWYG tools like what we've got or drag and drop tools, really like using a Wix or a Squarespace to just drag and drop content in, and then it works. Okay, so giving you a bit of a background on the landscape of AR, and it's fairly multi-flavoured, and we certainly wouldn't expect that people would necessarily know about all of these different flavours, but I think it's important to have a sense of what they are because there are quite a lot of them. And we'll go through them quickly one at a time. So we've got location-based, and we divide this into two types, being relative, which is relative to the user, I guess, and fixed location. So fixed is where you're looking at your exact position on the face of this planet, and mainly that is determined by GPS and based on your GPS coordinates. And then you've got relative to you. So that is how far away, a relative location is how far away it is to the person interacting with that at any particular point in time. And then, of course, you've got orientation as well. So you can lay out content relative to the way or the direction in which someone's facing, or even relative to, you know, a compass point as well. So in this scenario, locations, I guess, and from an educational standpoint, can become real-world learning objects, or I guess ROLO is what we call them for short. So we know that a learning object is basically a collection of content items, practice items, and assessment items, and that term's credited to Wayne Hodgkins and the related 1994 IEEE working group that he was part of. And they defined a learning object as any entity, digital or non-digital, that may be used for learning, education or training, but the focus is very often, I guess, on the digital side for that. And a real world learning object is very similar, but it's different in one key aspect, in that it's got both digital and non-digital elements kind of integrated into a single experience, if that makes sense. So I guess you can say that real world learning objects are real world kind of things or places seen through a digital lens, which kind of provides relative or contextual learning content at that particular point in time in that particular location. We then go on to kind of computer vision, and you've got a couple of facets around here. So we've got, the first one is visual search. So if we're thinking about it from the perspective of holding a device over an image, for example, we've got image recognition. So that's the ability for the computer to say, I know what this image is that I'm recognising here. And then now I know what it is. If it has some content or an action related to it, then that triggers that to either happen or display. There's obviously a lot of complexity around that. At a really, really simple level, what it does is when you hold up your device, the camera takes, in essence, a photo of or a snapshot of that image. It takes it back to grayscale, and then it does pattern recognition of what is left. So all of the unique points and corners and things like that, and then matches that against a database or a set of images and picks out the ones that it's closest to, or the one that it's closest to. You've also got object recognition, and same happens with facial recognition as well, and pose recognition. So you've then got what's called tracking, and there's a few different definitions of tracking. So if we think about image recognition itself, tracking is if I recognize, or if the computer recognized an image and said, for this image, I want to overlay a digital object, which we're going to do a little bit later, over the top of this, then how well that digital object tracks to or sticks to that image when you move it around or you move your device around is what we define as tracking in that sense. You've also got, if I play this, it's just got some background noise there. You've also got kind of ARKit and ARCore. So this is an example of those. So ARCore is Android's AR framework and ARKit's Apple's. And they enable developers to access kind of core operating system and specific AR tools that are built into that to add things like tracking the device position in the real world. But don't get it confused with actually locating something in the real world, like where you're located from a geospatial perspective. It can identify surfaces in the real world. So this identifies ground planes. So it enables you to put this portal, if you like, on a ground plane and feel like you're moving through it and looking into the real world. And then you've got space tracking as well. So the predominant definition for this is, or technology for this is called SLAM, which is kind of came about from robotics, where robots needed to know where to go and where they'd come from, and so needed to basically come up with a mapping coordinate system that they could know how to navigate the space in which they kind of were moving. And then you've got depth sensing, so the ability for cameras to understand how far away or how close you are to certain objects within a space. And that uses, you know, RGBD cameras in devices. So these are moving from computers into mobile devices at the moment. So if anyone knows about the Project Tango or the Tango devices that Google has, they've got depth sensing cameras in them. And then you've got different physical input as well. So everything from touch to controllers to sensors. And then we've got different modes of mixed reality kind of layered on top of that. So way back in about 2009, we came up with different, what we thought or what we perceived as the different modes of accessing this type of content. And at the time, personal was really predominant. And we were just starting to see the emergence of kind of the public and the private, but intimate really wasn't in the consumer space at all. So public is really where you've got, in a large public space, you've got a projector set up, a camera, and your whole body is really in field of view. And you've got personal, which is a camera, which is really just what we're seeing in this camera view here. There's fewer spectators, quite often just one on just you, but it's really easy and quick to distribute. And then we've got private, which at the moment is the predominant mode with mobile devices. And then we're moving into that kind of head-up display area as well. But if we think about AR and VR in learning, we can almost say that we're on the cusp of a bit of an immersive learning evolution. I wouldn't call it so much a revolution. So it's kind of time that we start thinking about, or a really good time that we start thinking about why and how is mixed reality a powerful medium for learning, and how does mixed reality enhance kind of that real learning. So we kind of think that this is a perfect bridging tool for blended learning. So it enables teachers and students to kind of seamlessly bridge the real and the digital worlds. And that kind of mixed reality and blended learning is really the perfect pedagogical partners. And for us, this modern version of the web now that we're seeing makes them more open and accessible than ever. But it's time to kind of think about, I guess, what skills does this facilitate? So both from an interaction and a creation perspective. And in a few slides, we're just going to talk about, these aren't necessarily new skills that you need to learn. It's more about taking the skills that you've got, enhancing them or transferring them into this space. So I think that's really important to be aware of, is it's not, yet another thing that I have to kind of learn. It's about saying, I know I've got these really deep skills and they can be easily adapted into this space. Absolutely. So how are we going for time, Lynn?
Yep, you're fine.
Oh, cool. Awesome. So let's skip ahead a little bit though. So I think, in this space is where mixed reality approaches can become really valuable learning aids. So if mixed reality is web-based as well, it means that you can kind of really seamlessly integrate it into, especially from an online learning perspective, into other online learning modules. And it doesn't have to be that kind of standalone experience. If you don't have to download an app to kind of experience it, then you can just integrate it with other learning content really easily. And people don't have to stop what they're doing, go away, do something else and come back to it. At Macquarie University, Matt Bauer, who's one of the professors or associate professors there, has kind of referenced AR as being perfectly situated scaffolding when utilised for learning. So it really does come into play as a good aid if used kind of, good, not evil in that respect. So I think getting into kind of practicality land here, there are a few, and this is very, very high level, but hopefully it'll start getting you thinking about some of the ways in which, if you're starting to create AR or even VR experiences, and this applies absolutely to both, the types of things that you need to consider as you're both planning and kind of creating these experiences. So I think one of the most important is that when you're creating online experiences currently, you're working predominantly within a two-dimensional space that's largely linear. And so now you're really moving into this spatialized kind of creation and learning environment. And so for both creators, and again, I really think creators are everyone from, creative technologists, learning designers, teachers, academics, students, it's literally anyone. I don't really see, singling out as anyone can't do this kind of stuff. And I think, and to the consumers of the content or the audience that you're introducing these to, you've got to be really, really, I guess, focused on the fact that it is a spatialized environment. And I think when you're doing that, you kind of take those core principles that you've established when you create standard lesson plans or experiences and those online experiences, and see how you can adapt them into this space. And again, planning is absolutely key. So whether it's really high level or you're doing kind of those iterative creation loops that become increasingly higher in fidelity each loop, planning is absolutely tantamount. And then the onboarding process. And this is where I think many of the kind of AR experiences kind of at the moment fall down a little bit. VR not so much. I think a lot of the VR stuff coming from a gaming background, they do onboarding pretty well. But AR, you've really got to think about how your audience is going to know how to interact with an experience. So for example, if you just think about image recognition, so someone being able to hold their device over an image and unlock some additional digital content, how are they going to know that that image that looks like any other image has actually got additional content that's able to actually be unlocked on that? You've got to understand, kind of what devices are they using as well, and what are the different capabilities, I think, of those devices. And if someone's got a really old device, is that going to be supported? And if not, how are you going to let them know that's not supported? And quite often from that perspective too, we found that a lot of people with older devices are not going to engage with these types of experiences anyway. So, sometimes just giving them an alternate, simple experience or an explanation as to why they can't access it is enough, and that's all they need. Or giving them even a video of that experience so they can see kind of what they're missing. And really importantly too, because this is really working with real world spaces, having an understanding of the physical environment that someone would be in when they're accessing this experience you've created, I think is key as well. So often the environment where people are going to be accessing these AR experiences is really variable, and you don't have a lot of control over it. So if you're using, say, image-based AR, this is one where you may have a good sense of what the environment's likely to be like. You might have a student who you're asking to access additional AR content by scanning a diagram of the anatomy or something like that in a textbook. So you know that they're probably going to be quite close to the textbook, that their light source is probably going to be behind them or just in front of them, and that they'll probably quite easily fit the whole of that image that you're asking them to scan within their device viewport. So, it's a relatively controlled environment. But what if you're using a poster, and Lynn will relate to this with some of the work that you're doing, as you trigger image and that poster's in multiple locations, and those locations have varying physical attributes that in turn can, impact the experience that someone has when they try and interact with that. So things to think about there are, well, how many people are going to be interacting with this poster all at once? Maybe it's just one, but maybe, there's a throng of people that kind of rush to it, and kind of jostle. And believe me, I've seen that, especially with younger students. They kind of want to get in there and do it. And then for some of them, invariably, they're not going to have it work particularly well for them. What's the light source? How high are those posters? How far away are people going to need to stand? Are there going to be physical objects in the way if they have to stand too far back? And what type of paper is that going to be printed on as well? Is it really glossy, and is the lighting source really strong so you're going to get reflection off that image? And in that way, that's going to impact the experience they have as well. So if you think back to that image-based tracking that we talked about, which was the ability for your digital object to basically track with that image and stick to that image. If you've got a really glossy poster and a really strong light source and you've got a lot of reflection, you're going to impact that tracking capability as well. The other thing is test early and often. Testing can't be underestimated in this environment. you really need to test across as many different variables as you can, and using as many, if you're wanting the widest possible audience to be able to access it on the broadest amount of devices, then you want to be able to test across a really good cross-section of those as well. And then inclusiveness, and I think this is where the web really does come in. So, and we talked a little bit about unsupported devices, but developing for a single platform or being able to output easily for different platforms is really key as well. And then, even though we've kind of talked about a lot of technology specific labels today, for your audience, most of the time, they don't care or know what it is. They just think it's magic when it works. So really try and avoid technology specific labels where you can, and just talk about the experience and then let the experience speak for itself. So I guess it's also, you know, I like to think that we use this technology for good, not for novelty in a lot of cases. But really make sure that the experience fits the context or the goal, and make it as simple as you absolutely can. And I think one of the biggest questions is, where does the content actually come from and how does it get created? So I'm a massive fan of repurposing. I think having spent, you know, a significant amount of time in the kind of content creation area and content management area and putting together a lot of different content experiences, I kind of roll my eyes whenever, you know, someone says, oh, we need to redo this again in another way using a different, you know, technology or platform. Massive fan of repurposing. So existing content, how can it be either used as is, reused as is, or tweaked slightly to do that? And I think from our perspective with OAR, we support the ability to add content that is just 2D images, 3D models, 2D kind of linear videos, alpha videos, just standard kind of polygonal shapes, that type of thing, text-based content, audio content. So really it's thinking about, instead of what's all this new content I need to create, it's how can I take the existing content and make it more immersive, engaging and compelling, and reuse as much as I can within this new kind of, I guess, space, the learning space that we're creating. So the other kind of places you can get content, I think Nat and Claire, Lynn mentioned, Nat and Claire talked about this last week, is there's a bunch of kind of stock library content around at the moment, and more each day in both the 360 content, which is where you're kind of creating that, you know, almost like a VR scene, where you've got 360 images or videos of scenarios or environments. So Flickr's got a whole lot of 360 Creative Commons licensed content. You've also got places like Pond5 and Video Blocks, I think, and Storyblocks that have a lot of that content. Obviously it's paid for, and even iStock and Getty Images, although some of the Getty content is prohibitively expensive. But, you know, most of them have, and even Envato Elements has some, so most of that is either free or relatively low cost. From a 3D content perspective, you've got a lot of free content at the moment that you can download from some of these libraries and then adapt for your own purposes or use straight away. Or you can download it very cheaply, or you can engage kind of people on those libraries to create or kind of tweak or edit that content for you. And I'll send Lynn through a bunch of links for all of these, but some of the places for 3D content is TurboSquid. Google has their own low polygon 3D library at the moment called Poly, so it's just poly.google.com. So that, you know, there's a bunch of places to go. Like I said, thinking through the onboarding process is critical. So what instructions do you need to give to people for them to be able to use it? And what are some really nice, unobtrusive ways and simple ways that you can either give them the information they need up front, or you can do it in a way that you provide it to them at the point of need. And I think that's super important. And that's, you know, that's nothing new, I'm sure, for any of you. And then really making interaction patterns consistent so that you make it feel familiar to experiences they may have had before. I think it's important to remember that, you know, there's no real stat here, but my stat, which, you know, I've made up is, you know, there are 99% of people who haven't actually tried AR experiences before. So a lot of people have said, I know what AR is, and they might have seen some videos, but they haven't actually interacted with it themselves. It's fairly extraordinary how many people you come across that don't. And I think we're in this space and we often forget that. And then absolutely be inclusive. So try and aim for single platforms rather than fragmented silos, and think about, all those things that we talked about. So really quickly, how easy is it to use web-based AR? If you've got a phone or tablet, open up so if you've got an iPhone or an iPad, you need to be on iOS 11 or above, and Android on 7 or above, and using the Chrome browser. And so with iOS, just use Safari. But if you open up your web browser and enter magic.or.io and just point your camera at the image that you see on the screen, and then you'll see on there just an example of some 3D content, some image-based content, and some animated or animation of that content. So I'll give everyone about 30 seconds. And if it doesn't work for anyone, feel free to put in the comments as well, or in chat, that it's not working. Lynn, did it work for you? I can only see people. Awesome.
Yeah. I clicked on Mr. Rabbit. No, that's great.
Sandy, that's really interesting. You had to install Google VR services first. I might ping you about that, because that would be cool to understand a bit more about that. So does everyone want to just see really quickly how we can create this in kind of 30 seconds or less? So we create a living image. So if we take the image that the UImagine team has created for this season, which is the one in front of us here, and I am going to skip out of here. Oops. This one into here. Can you see my web browser? Yep, great. So this is just using our OR tool. You can edit across any device as well, so not just on computer, but do it on phone or tablet. And we're just about to release editing inside a head-up display as well with controllers. But we've got that concept of wanting to AR enable an image. So this is our image, our trigger image or our target image, which I've added before, and it's just simply identifying the image, it uploads it, and it processes it for use. And then I'm in my editing tool here. I can go and say, I now want to add some objects to this. So all of a sudden, instead of being in a 2-dimensional environment, you can see I'm in a 3-dimensional environment, because that's like the real world. Because in that way, you might actually want to not just overlay objects directly over the top of this image, but you might want to start off when it loads, putting them behind the image or behind the viewer, and then animating them through, or only bringing them through when another kind of action triggers that. But we'll just lay it over the top for now. So if I go into my media library, and I can see some content that I've added previously, but I'm going to add a 3D model. So there are 2 types of 3D models we support. There's kind of static models in OBJ format, which is the most common format, and also models with animations already built into them. So we support the FBX format with those. So we'll do an animated model, and I'll show you how to do that. So we just say I want to use that model, and then that puts it kind of over the image, and I can say I want to place it. Now it's there, I can actually transform it, edit it, and add actions to it. So I just click on it to select it, and I can scale, rotate, or move. And it's as simple as clicking on it, and then just from a computer perspective, using the mouse or trackpad to make it bigger or smaller, or entering the values directly in up here. And then I can say move my model. I want to move it down, so I select the y-axis, move it down to the middle, and then OK on that. And then what I want to do is when somebody taps on it as an action, I want that model to actually roll towards me. And I know that this model has an inbuilt animation that's all about rolling. So I click on this little more and I say I want to give it that animation. And so I say I want to play the animation when someone selects that object. I don't want to give it any delay. And I can choose my animation. So I know it's a clip animation in that model. I choose the model. And then this has just got one animation, but sometimes they've got a whole set. I'm just going to leave it as the default and then just click done on that. So simple. So in your web browser, all you need to go to now to test this is just this first bit of the URL. So weimagine.org.io. And then that should load. You need to allow your camera to access the web browser so that you can see that real world coming through. And then I'm going to go back to PowerPoint here because that's the image that you're going to need to hold your device over. And then if you tap it, when you see the object, then he should roll towards you. And hopefully that worked for everyone and they can see how easy it was. Yep. Yep. Sorry, Ellen. So that was just weimagine.org.au. So, whoops, not we, hang on 2 secs. There you go. And then very, very quickly, you can do a whole lot of things to this as well, but we've set it up so you skip scan. So you can have an interface that tells people to specifically scan it or not. And then we can also do things like lock the content. So you'll see that if you move away from that image, the content disappears. But if we have lock image on, then it provides a little lock for the user to actually say, I want to be able to lock it and move away from that image and still interact with the content. So lots of really easy kind of configuration options there. But that's just a really small taster, given the time we've had. So basically here, I think, you know, this speaks for itself. So this was, I think, a sample of, I think, 500 teachers or educators across America towards the end of last year. And they were really excited by the possibilities they saw in mixed reality, which I think is amazing. And I think right now, is a perfect time to explore these technologies. There's no real rules laid down. There's no real best practices defined. And if anyone said there were, I'd really challenge that at the moment because I really see most of our customers are outside Australia. And I think in the education space especially, we're seeing most people in that exploration phase at the moment. So getting their heads around it, understanding what they can do, and then trying to see what's working, what doesn't work, tweaking, that type of thing. And I think the really interesting thing, and this works really nicely in Web 2, is that each one of these objects becomes a learning object that is trackable and auditable. And then you can actually integrate that into learning management systems as well. You can create immersive assessments and that type of thing. So I think, you know, it's a great time to kind of see how this technology is going to fit into the learning or into the education environment. So I'd just like to say thank you, everyone, for their time. As I said, I'm going to send a bunch of links that are kind of ranging from quite academic, some quite technical, some more philosophical, and some just fun as well. So yeah, thank you very much.